That don't kill me, can only make me stronger. I need you to hurry up now, cause I can't wait much longer. I know I got to be right now, cause I can't get much stronger. Man, I've been waiting all night now, that's how long I've been on ya. Let's get lost tonight. You could be my black Kate Moss tonight. Play secretary, I'm the boss tonight. And you don't give a what they all say, right? Awesome, the Christian and Christian Dior. Damn, they don't make them like this anymore. I ask this, I'm not sure. Do anybody make real anymore? Bow in the presence of greatness, cause right now that has forsaken us. You should be honored by my lateness, that I would even show up to this place. So go ahead, go nuts, go ape. Especially in my pastel on my page. Act like you can't tell who made this new gospel, homie. Take 6 and take this, haters. That don't kill me, can only make me stronger. I need you to hurry up now, cause I can't wait much longer. I know I got to be right now, cause I can't get much stronger. Man, I've been waiting all night now, that's how long I've been on ya. Me like it. I don't know if you got a man or not, if you made plans or not, if God put me in your plans or not. I'm tripping, this drink got me saying a lot, but I know that God put you in front of me. So how the hell could you front on me? It's 1,000 yous, it's only one of me. I'm tripping, I'm caught up in the moment, right? Cause it's Louis Vuitton dine night, so we gon' do everything the kind like. Heard they do anything for a Klondike, well I'll do anything for a blonde. And she'll do anything for the limelight, and we'll do anything when the time's right. Baby, you're making it faster, stronger. That don't kill me, can only make me stronger. I need you to hurry up now, cause I can't wait much longer. I know I got to be right now, cause I can't get much stronger. Man, I've been waiting all night now, that's how long I've been on ya.
Raz, dva. Raz, dva. Raz, dva. Raz, dva.
All right. Ready to go, or give it a few minutes?
Probably if somebody gonna come, doesn't matter. It's a few minutes late or something, we can maybe start. Maybe I can give you some introduction or something. Maybe in Slovak, if you don't mind. Okay. Dobre, čaute všetci, takže pomaly začneme. Keď ešte niekto dôjde, tak snad sa nejak pripojí. Chcel by som vás tu privítať na ďalšej session GDG Bratislava. Dneska tu máme Grega, ktorý prišiel z Firebaseu, priamo v podstate ten patrí Google, čiže priamo z Google, z USA. A niečo nám tu povie o Firebase ako takom a pravdepodobne najviac informácií bude ku Firestore databáze, na ktorej priamo pracuje. Takže užite si to, určite má pripravených kopec zaujímavých informácií. Keby ste chceli, tak máme aj slajdu. Tak je GDGBA, všetko malé, kľudne spolu. Čiže dávajte otázky, na konci sa na to pozrieme, ak na to nezabudneme, ale prípadne však môžeme dávať aj priame otázky, ak budete chcieť. A tak zatlieskajte Gregovi a môžeme asi začať. OK, it's yours.
All right. Moje meno je Greg Soltis. All right. Hi, everybody. My name is Greg Soltis. I work at Google. Specifically, I work on the client SDKs for Cloud Firestore. So these are the libraries that run on Android and iOS and on the web to allow applications to talk directly to the backend database. And today we're going to be walking through a code lab to use Firestore on the web to build an application. And I just want to say, before I start out, if you don't have NPM and Node maybe start downloading it now because we'll need it to run things. It's not needed to actually run the application, but for some of the build step and dependency stuff, you'll need it. So, all right. Does everyone here know what Firebase is? Is everyone familiar with it? Yes, a little bit. So, if you haven't looked at Firebase in like 4 or 5 years, things have changed a lot. It is now Google's platform for mobile development tools, things to help developers. So parts of it are like helping you build your application, which is things like Firestore, things like the real-time database, things like authentication or hosting. There's things for helping you improve the quality of your application. So there's Crashlytics is part of it. There's performance monitoring. And then finally, there's analytics. So figure out what your users are doing, figure out how to improve your application for segments of users, all sorts of things. So I work on the development side, helping developers build better applications. And specifically, that's what Firestore is for. If you're familiar with the real-time database, which was Firebase's original product, that was you could write a client-side application, no server process at all. Your clients would talk directly to the back-end database. Database where you don't need a server. You can have client applications talk directly to the database. You get live updates as things change, but now you have it on a just massive scale. So that's what we're going to be using today. We are going to be building a small restaurant review, search and review site using Firestore, and it'll just be a web app. We won't need a server for it. It's just going to be talking directly to Firestore. So, as I said, you'll need NPM and Node, and then a text editor of some sort. Okay. Are there any questions about Firestore before I start? What it is, or we'll get more into it. So, okay. Yeah, like I said, it's a massively scalable database. It is a NoSQL database. It is a non-relational database. So it's not going to be your typical SQL queries like MySQL or Postgres or something like that. Scalable, multi-region, you pick where your data is hosted. So I know we have a bunch of European data centers. Would probably make sense to pick one of those, but it depends where your customers are. You can basically host things where your customers are. All right, let's get to the code lab. All right, things we're going to use. Cloud Firestore, like I mentioned. Firebase authentication is a service that lets you log in and keep track of your users. So I've been saying that you won't need a server process for this, but to authenticate users, you typically need some sort of trusted service. So Firebase provides this, and there are a variety of ways that you can allow users to log in. So there's a bunch of social methods like Facebook and Twitter. You can use Google, of course. You can use email and password. We are actually going to use what's called anonymous authentication, which is the user doesn't have to sign in at all. We're just going to assign them an ID so that we can remember who they are when they come back to the site, but there's no identity associated with them. Firebase hosting is serving static assets. So since we're building a web app, that will be useful. And then finally, the Firebase CLI is a command line tool that helps kind of tie it all together. It lets you start projects. It lets you associate the application you're building with the project. Lets you deploy. We'll be using it a few times. Okay. This is where you can find the instructions for the code lab. I'll have them up as well, but you may want them for reference. This is going to be, or it should be, a Git repository that you'll want to clone. I'll give everyone just a second for that. So you should be looking at something, oh, sorry, the web link goes here. We'll get to the Git repository. You should be looking at something like this. This shows what we're going to be building, the restaurant review site. So the first few steps are setting up Firebase and your Firebase project. You probably can't all read that. Hang on. There we go. Is that a little better? All right. So this project is going to require a Firebase project to be created. This is going to be the thing that encapsulates all the different services you're using, the big one being Firestore. So we're going to go ahead and create that. Console.firebase.google.com. Let's see if I have my... Uh-oh. Hold on. So,
You're successfully authentified.
Yeah. All right. Cool. So I've created mine already, but I haven't done any of the setup yet. So let's wait for this to load. Once you create a project, you should be looking at something like this. Is anybody stuck? Okay.
Could you please show the link of the repository?
Yeah. So the, oops. There we go. Sorry, this should bring you to the instructions. We'll get to the repository in a minute. Yep. Okay, created a project. So I mentioned we were going to use anonymous authentication, so we're going to go and enable that first. So see up here it has authentication on the side. Just go ahead and click that. And then at the top there is a link for sign-in method and then anonymous, and just click enable and save. So what this is doing is just telling Firebase that we want to be able to track users without forcing them to sign in. If you're building a full-fledged application, you might consider some of these other sign-in methods as well, but for the purposes of this, we're just going to do anonymous so we don't have to worry about building a login page. So that's the instructions for that. Okay. The next thing we are going to do is enable Cloud Firestore. So under database, should see something like this. And then just click Create Database. And you will get a pop-up like this. So has anybody used the real-time database before? Then a couple people. If you've used it, you may already be a little bit familiar with the notion of security rules. So we'll touch on this more later. But just briefly, security rules are what make it safe for your application, your client application running on an untrusted device, right? Your user's phone or their web browser. It's not something you control, but you still want it to be safe for them to talk directly to your database and even make changes to that database. The way you handle that is by writing security rules that specify what's allowed. So in our case, well, in locked mode here, they're saying nothing is allowed. Allow read, write if false. That will just deny all access. And the idea is that as you build your application, you figure out what specific actions you do want to allow, and you write rules for it. In our case, we're going to start in test mode, which is the opposite. We're going to allow anything from anyone to start with. This is only, like as the name says, it's test mode, really only when you're developing your application. Before you really know how you're going to be using everything, this makes it easier to get started, to figure out what operations your application is going to need and what you will eventually want to allow users to do. So go ahead and click Start in Test Mode and then click Enable. Okay. Again, this might look familiar for those of you that have used the real-time database before, but this is showing the contents of my database, which since I just created it, it's empty. But we're going to fill it with our application in a few minutes. Firestore is a little bit different from the real-time database in terms of the data model. So the real-time database gives you one big JSON document, and you can nest it as much as you want. In Firestore, we've encoded the notion of collections and documents. So whereas before the entirety of your real-time database could be just like the Boolean true or the constant 3, you can't do that in Firestore. You have to have collections, and collections contain documents. But like the real-time database, it is still hierarchical, so you can actually nest collections inside of documents, which we're going to do in this application. So you'll get to see an example of that. Our top-level collection for this application is going to be restaurants. We're going to have a set of restaurants that we'll be searching and reviewing and things like that. But for now, it's empty. Again, like the real-time database, you can make changes here. You can go and add a collection, and you can add documents if you want. This is mostly for, again, while you're developing and sort of figuring out what you want to do. Once your application gets going, you probably want to use something like the admin SDK to actually make changes to your data and treat it like you would treat normal database migrations. So, have somebody review it and run a script rather than going through and clicking manually on a website. But for getting started and playing around, this can be a helpful tool. Also for diagnosing problems. If you find some data that's unexpected or something like that, this is a good viewing tool for it. Okay. We did the security rules. Okay. Here's the Git repo. So in this Git repo, we have done the skeleton of the app already. What's missing is the actual data access. So if everyone wants to go and clone this Git repo, I'll give you a minute or two to do that. That's where we're going to be editing code. Does anybody have any questions while we're doing this? Okay. Okay, almost done with all the setup stuff. The next bit is to install the Firebase CLI. So like I said earlier, this is a command line tool that helps you interact with Firebase as the developer. So you can associate a project like your Git repo with a particular Firebase project. You can do deploys and things like that. But this is not generally a project level dependency. It's more of a system-wide tool, so hence the npm-g. So just be aware of that. And then you should be able to tell that you have it installed with Firebase -- version. Oh, that's tiny. All right, my NPM is out of date, but I have the Firebase CLI installed. So everybody has the Firebase CLI? All right. Okay, so now we are going to associate this Git repo with the project that we just created. So this is a two-step process. We're going to log in to the Firebase CLI, and this should pop up a browser window where you log into the same account you used to create the Firebase project. So that will tell the CLI basically who you are and give it access to your account. And then the second step is telling the CLI, okay, for this project, for this repo, we're going to be using this particular project. So let's go ahead and do that. Oh. And then once you're authenticated, you can close the window, and you should see something like this in your terminal. So now the CLI has access to your project, and that means we can manipulate the project from the command line tool rather than having to click around on the website. Let's get back to our steps. Okay, so the next step is to associate this project, or the Firebase project, with the application that we're building. So Firebase use -- add. And then I have a couple of projects. So if you also have projects, it'll pop up a list for you. Select the one you just created, and then you can give it an alias if you want. I'm just going to call it default. All right. Has everybody managed to set up which project they're using for this application? Is anybody stuck? Okay.
Can I ask a question?
Yeah.
I'm using
Interesting. Yeah, I'm not familiar with Git Bash. All right. So now we're going to actually see what we're starting with. Firebase serve will just run, sorry, let me back up. Should do this in the repo that you checked out. So make sure you CD into that directory. Firebase serve is going to run an HTTP server, and we can just open up the project in a browser. So yeah, you should see something like that in your terminal, and then all right. In your browser at localhost port 5000, you should see something like this. So this is the skeleton of our application. And as we saw, we have no data yet, so there's nothing to display. But we are up and running. We now have something to edit, and we can start building. Is everybody able to get to here? Like this is all the setup, and now we get to actually using some of the stuff. All right, cool. So the first thing we're going to do is we're going to talk about writing data. So we don't have any restaurants yet, so that's not very good for a restaurant rating application. The skeleton code includes a little bit of JavaScript to generate some random restaurants. And what is it actually going to generate? Well, it's going to generate JavaScript objects that look kind of like this. Each restaurant will have a name and a location. It's going to have a price that's 1 to 4, just how expensive it is. It'll have a category, and then some statistics like number of ratings and average rating. And initially, we're not going to have any ratings, so those will both be 0. But we want to go ahead and generate a bunch of these, and then save them to our database. What we're going to do is we are going to take these JavaScript objects that the project is producing, and for each one, we're going to write it into a new document in the restaurants collection. So the restaurants collection is going to be a collection of documents where each document represents a single restaurant. And this is just kind of a basic starting schema. So let's look at that. Come back later and talk about ratings. Does someone have a question? Okay. So in the project, there is a file under the scripts directory called friendlyeats.data.js. And the first function in there is this add restaurant function. So you can go ahead and copy this from the instructions or from up here into the body of that function, but I want to just talk through what's going on here. So the project has installed Firebase as a global, the whole library is there, and then Firestore is just saying, okay, I want the Firestore portion of Firebase. It starts to get interesting with this collection method. That's going to say, okay, you give me the name of the collection, and I am returning a reference to that collection. And a reference to a collection lets you do several things, but one of the things you can do is add to it. So we are going to add the data that we're passed in here, which again is that restaurant data that we saw earlier. This function is going to get called for each restaurant that the project generates. And so for each one that it generates, we're going to add a new document to that collection via the collection.add method. So I'm just going to go ahead and paste that in. So if you save that and then refresh this, okay. So nothing's changed because we don't have any data yet. But if we push that add mock data, it's going to go through and call our function for all the restaurants that it generates. So let's try that. Okay. So right now, it's generating a bunch of restaurants, calling that function over and over again, and we still don't see anything. We haven't implemented reading yet, so the restaurants are there, but we can't get at them. However, we go back to your console. Here are all my restaurants. So again, this is a good way to kind of explore your data a little bit. You can see I have a bunch of documents that look like that object we saw in the slides a minute ago. Each document, since I didn't specify a name for it, was given a random name. One other difference from the real-time database, for those of you who are familiar, is the real-time database would try to order those names by time. These are just random. There's no timestamp embedded in them or anything like that. If you want things sorted by time, that's something that you can do, but you need to include the time in the documents that you're writing. So just a note for those of you who are comparing the two. And if you click through here, you can see a bunch of different restaurants. Was everybody able to get restaurants written to their database? Is anybody having trouble? All right, let's move on to reading. So I should mention that this didn't go through any server process. It was the JavaScript running in your browser talked directly to Cloud Firestore. You didn't have to write sort of a server process where you send the data to your server and then your server takes that data and turns around and sends it to the database. That's one of the cool things about Firestore is that that step is just eliminated. You go directly to the database. Okay, now we're going to display data. This is a two-step process in this project. So we have a function in there already called getAllRestaurants, and it takes a renderer. And what we're going to do is we want to read some of the restaurants from Firestore so that we can display them on the page. The first step we're going to do is construct the query that is the restaurants that I want to see. And to start with, we're going to say, okay, we have our collection of restaurants. We want to order it by average rating because we figure we might as well show the best ones first. And then, since who knows how many restaurants we have, let's just take the first 50. So that's order by, and then limit 50. And that gives us a query. Queries are similar to collection references in that there's a whole bunch of methods on them. You can't add to them the same way as you can add to a collection reference, but you can read from them. And that's what we're going to be doing in the second step, the get documents in query. So let's everyone go ahead and just copy this into getAllRestaurants. And then we'll talk about the second step. Okay. This next function is get documents in query. And the idea behind this is that we are given a query and that we're going to find the documents that match that query. And for each of the documents that match it, we're going to do the correct thing with that renderer. But what makes Firestore cool and the real-time database cool is that this isn't going to happen just once. We're actually going to be subscribing to all of the changes in that query so that the first time we run it, we're going to get, okay, we've got 50 restaurants, and we're going to cycle through the changes here and call the correct method on the render. But then let's say some user adds a new restaurant and rates it really highly, so it becomes the top rated restaurant. Well, now we're going to get this function called again, and there's going to be a change that says, hey, there's a new restaurant that matches this query. And also, because you only wanted 50, the top 50 have changed. One was added at the top, and the one at the bottom fell off the end. So this will get called again without you having to do anything. Some other user changed something, your code gets a callback. And that just stays that way until you unsubscribe. So this function actually returns a handle if you decide like, okay, I'm done with the changes, I can unsubscribe. In our case, we're just going to leave it. But this is the sort of like live updating query that makes Cloud Firestore and the real-time database cool. So if you go ahead and copy this in, we should be able to read the restaurants. There we go. All right, let's go look at that function some more. So what is going on here? Was everyone able to get restaurants showing up, by the way? Okay. Yes? All right. So what's happening is the first time you hit the page, this is saying, okay, I've gotten that query we constructed before that says, give me the 50 restaurants. Give me a snapshot of those 50 restaurants. And then the first time you don't have any data locally, right? You just hit the page. So all of the changes in that snapshot are like, there's a new document. It's a document added. So you're going to be hitting this branch when iterating through all the changes in the snapshot. And so there will be 50 restaurants in there. You'll loop through this 50 times and display the restaurant. The document in the change being the document representing that restaurant, and then the renderer knows how to display it. Are there any questions about what this is doing? Because there's kind of a lot packed in here. If somebody had added a new restaurant and bumped the last one off the end, the change type would be removed. So we'd be telling our renderer, remove that restaurant. Is there a question? Okay. All right. Okay, so everyone's got their restaurants showing. All right. So the next bit is talking about an individual restaurant. So we're designing this product, we're doing the restaurant reviews, and it might be cool to have the list of restaurants updating all the time as users add reviews or add restaurants and things like that. But let's say once you're looking at a particular restaurant, we say, oh, we don't want anything live updating anymore because a user is reading this or rating it or whatever. So we just want to grab the data once and display it to them. So you can also do that. You don't have to do the live updating on snapshot thing. You can just get a piece of data. So that's what we're going to do with get restaurant. So again, we have the restaurants collection, and then the doc method is saying, okay, I want a particular document from this collection, so we give it the ID, and then get is just going to return a promise for that document. So let's go ahead and copy that into get restaurant. And then if you go back to the application, you should be able to click on one of the restaurants. And we don't have any ratings yet, but you should see the data up at the top. And that's coming from that document that was read just once. And so that means if you're sitting on this page and maybe, reading about this restaurant or adding a rating or something, even if other users are adding ratings, you won't see any of that data change. Back on the main page you will, not here. Okay. Let's go back to the restaurants for a second. So right now, we are displaying 50 restaurants, the top 50 restaurants according to average rating. But that might not be super helpful. As you can see, these restaurants are located in all different places. They're all different styles. So if you are looking for a restaurant, you're probably interested in one in the place where you are, and maybe you have a style in mind or not. But either way, we need to be able to sort and filter the data a little bit. So that's what we're going to do next. So this is kind of a big function, get filtered restaurants, but it shows some more things you can do with queries. So again, we're going to get our query by just taking the restaurant collection, and then depending on what the user has selected, we're going to add some filters to it and maybe some sorting. So this is just saying, okay, I have this collection, but I only want documents where the category, that's the category property on that document, matches whatever the user said, or the city matches whatever the user said. Same with price. And down here, the sorting options we're going to give the users are average rating or number of ratings. Maybe something that has 5 stars only has 1 rating. That's not very trustworthy, so we want to see things that have been rated a lot. So what this is going to do is it's going to construct that query, and then we are reusing the same function we wrote earlier. That function is generic. It just takes a query and says, okay, for the things in this query, display the right things, display the right restaurants. So this is just demonstrating how you can build a more advanced query than just give me 50 restaurants from this collection. So let's go ahead and copy this in. And then if you click on this little thing up here, you'll get your sorting and filtering options. So let's see. Okay, I have one restaurant in Albuquerque. Let's see if I Okay, so if you play around, you should be able to sort of slice and dice the restaurants a little bit. But there is one thing to note, which is if you go and open the developer tools or your JavaScript console after having done this a bit, you will see some errors. So I'm not sure if you can read this, but if you're looking at your own, it says the query requires an index. You can create it here and gives you a link. So what this is saying is Firestore 2 to efficiently serve the particular query that you selected, right? The category or city or average ratings, it needs an index. Once you're combining multiple properties, you're going to need an index to actually efficiently run that query. So the constraint we're operating under for reading is Firestore wants to be able to satisfy your query by a single scan of a single index. And what it'll do when you have a small amount of data and you're just playing around, it'll say, okay, you don't have this index. I'm going to send all the data to the client, and the client already knows how to do sorting and filtering. It has that logic because it has to incorporate changes you've made locally to do it. So it can look like you're getting the right data, but you'll have this error in your console. And pay attention to these, because if you're going to have a lot of data or a lot of users, you're basically going to incur a lot of extra reads that you don't need when you should just build the index. So if you can go ahead and click on one of these. And you should get a pop-up like this, offering to create the exact index that you would need for that particular query. So once you have all the indexes created that you need, you shouldn't see any of those errors in your console. So I'm going to go ahead and create this one. Okay, so I clicked on one of the errors that I had, and it's going and building it. But I didn't try every possible combination, and there's obviously other indexes that I got errors about. So this seems a little tedious. You can do it, but there's a better way. So we have in the project this firestore.indexes.json file that includes the indexes that you want for this project. We've gone through already and said, okay, these are the ones we need. And then you can actually deploy all of these right away with the Firebase CLI. This is an alternative to just playing around with your app until there are no more errors. Is just sit down and think about the queries that you've allowed the user to construct, write out the index definitions, and then you can deploy all of them. And because it's wired into the CLI, you can do this as part of your deploy process for your application, right? So you add a new feature that requires a new query. You can actually tie this in, so you add it to your indexes file, and when you're deploying that version of the application, you also deploy those indexes. So if you go ahead and run that, you should see a bunch of indexes being created. Oops. Yeah, so you should see something like that. And if you go back to your console and click this indexes tab up at the top, you'll see a bunch of them are building. And they take a few minutes to build, but once they're built, you should stop seeing those errors in your developer console. Is this making sense to everyone? Are there any questions about indexes or? Okay. Yeah.
Is there a way to satisfy all possible combinations?
All possible.
We can have also all sorts of queries, so all combinations.
So you have to build the index for each one that you want. So you could just say, like, here are all the properties, here's all the different ways I want to combine them. But you would have to go and do that. Yeah?
During this process of indexing, is it safe to add more restaurants to the database?
Yes. Anything else? Yeah.
Does the index rebuild them itself automatically?
Yeah, as you add data, the index will be kept up to date. I should note that if you have an index on a property, let me think of an example. Maybe some of your restaurants, you have a field for owner, right? Whoever owns the restaurant. If you were to build an index on that property, but not all of your restaurants have it, that index would not contain any of the restaurants that don't have an owner. So the property must exist on the document for that document to show up in the index. Yeah?
Why is it so small on the restaurants?
I have a feeling mine is hosted possibly in California, so it's going back and forth to update, but
Is it updated on client side?
let me see. Yeah, there shouldn't be that many restaurants. It's going. Yeah.
As we add more restaurants, like are the indexes incremental building like a lot faster than this one?
Yeah. So once you do this initial bit, you shouldn't have to do this again. Like as you, by the time you get the acknowledgement for adding a new restaurant, so we didn't show it here, but when you add a document, you can also supply a function as a callback that gets called when the server has acknowledged your right. So like, okay, this restaurant is definitely present now. When that function triggers, when that callback happens, your index is already updated. Yeah.
What about more complex queries like rating, average rating, and rating between 2 and 3? If we have built this index, does it also apply to more complex queries? Or?
Yeah, so if you're just working on a single property, think the index will already exist. If you are, but again, you have to do a single scan. So your average rating is going to be like average rating greater than X. If you want to combine that with something else, then you'll need to build an index for it. So, sorry?
It's fine to build such an index. Like it's not possible to build index more complex index. I mean, it's enough.
Yeah. All right. So, okay, we've deployed our indexes. All right. Let's talk about adding ratings. Actually, let's go back and look at the data model for that. All right, so we have up at the top here a document for a restaurant. And I mentioned earlier that like the real-time database, you can nest inside of individual documents. So inside each restaurant document, we're going to nest a ratings collection. And that collection will itself have documents, each one representing a single rating. And the ratings, again, can be auto-generated by the skeleton app, or you can actually click and leave your own. But they're going to have data that looks kind of like this. So you get some text, and the part that we're going to care about is the actual rating number, I would think 1 through 5. But each restaurant will have this nested collection, and so you could say, you could write a query that says, for this restaurant, give me all of the ratings. Okay, but for adding a rating, it's a little bit tricky. Because we're doing this, well, I should mention that some of this stuff in an actual production application, you might not want to trust to the client. So for example, here we're calculating the new average. You could have a malicious client that, wants to tank a rating for a restaurant, just gives it a horrible average or something like that. So you would either need to include some validation in your security rules, or you might want to run these calculations in some trusted process. So something like Firebase Functions is a good escape hatch for that. If you find something that you don't want to trust your clients to do, and you can't quite specify in the rules in a way that doesn't allow any wiggle room for them, you could use Firebase Functions to say, okay, when somebody adds a new rating to a restaurant, run this little bit of code. And that bit of code could do this average calculation and write it back. For the purposes of this code lab, we're going to do it on the client because we want to talk about a transaction. So if two users are adding a rating for the same restaurant at the same time, and they're both calculating this average or both calculating the number of ratings, odds are one of them will get it wrong because they haven't seen each other's rights. So, if there was one rating and two users are each adding their own rating, you want to end up with 3 ratings, not 2. So we're doing this in a transaction, which means all of the rights in here and all of the reads need to be atomic and consistent. So the way to do that is some of this stuff is familiar already. We're going to get the restaurants collection. We're going to get the document for the restaurant that we care about. And then this gets us the nested collection, calling .collection on the document. So we're going to say, give me the ratings collection for this particular restaurant. And then just calling doc like that will give you a reference to a new document. So this is one that doesn't exist. There's no data there, but we now have a reference to it. And that's what we're going to be writing. So now we're going to start a transaction. We call run transaction, and we get this transaction object. And what this transaction object does is it lets us funnel all our reads through that. And what that means is the values we see from those reads are guaranteed to be what the values are when our write is committed. So we're getting the restaurant document here. This document is the same there. So because we're reading the restaurant document in the transaction, we know that the average rating for the restaurant when we go to write our new data here is going to be the same. Like nobody will have changed it while we weren't looking before we could get our rating in. So this is pulling down the restaurant data and doing just a little bit of math to figure out our new average based on the average from this user. And we are incrementing the number of ratings because we're adding a rating, and then we're going to save it back. So this is all done client side, and that means somebody could have gone and added another rating while we were doing this, and what happens then, right? That somebody got that second rating in before we did, so we go to save our data that also says, our number of ratings is 2, and the server says, well, actually, this restaurant document that you read for this transaction is out of date. Somebody's changed it since then. And so the client says, okay, that's fine. We'll just do it all over again. So we go and read the restaurant again. We do the math again. Now we've got number of ratings 3, and we save it again. And the server this time, if nobody else has added another rating, says, all right, nobody has changed anything since you did your read. I accept you're right. This is the new state of the world. That, depending on how much contention there is, that could happen a number of times. So it's important for this function to be just a function of your reads and the change you want to make. Because this could get called 2, 3, 4 times, depending on how many people are trying to update the same document that you're reading. Does that make sense? This is one of the trickier concepts in Firestore. This is similar to how the real-time database does it, if anybody's familiar with that. Quick. There is one important difference, which in the real-time database, your transaction lock was basically a point in the JSON document, and if anything below that point changed, you would have to rerun the function. Firestore is a little bit smarter, and it's only locking the individual documents that you read. So that means if you read one restaurant, you don't have to lock the entire restaurant's collection, or if you read 2 restaurants, you still don't have to lock the entire collection, just the actual documents that you read. Are there any questions about transactions? Yeah.
Is there any notification when the transaction was properly propagated to the database?
Yeah, so like the add function, you can supply a callback to run transaction. So you will get a callback in your code when the server says, yes, okay, this was applied. Any other questions? All right, let's go ahead and we'll copy that code in. And then make sure you're running your server again. Is it running? Yeah. Oop. There we go. And then you should be able to go ahead and add a rating. So if you click on the plus in one of the restaurants, thanks. There we go. Now my restaurant has a rating. Is everybody able to get this working? Yeah. Hmm? Yeah.
So basically, when it logs the document, when we say, when we return a promise with it returns the object with the transaction returns the object with the document, kind of, right? And then it logs. And where they log.
The transaction.get, is that?
Yeah. Here, when you get, or, I mean.
So, yeah, let's go back to,
Like, for instance, I will be doing using a couple of documents in the transaction.
yeah, so this right here, this transaction.get is returning a promise. And you can see it's using the document data there. You can do a bunch of those if you want, right? You can get a couple of documents, and what's going to happen is the client is basically going to remember the version of those documents that it read, and that's going to be, that data will be sent along with your changes, and the server is going to check that those documents are still at the same version.
So what happens when you get, right?
It's
More or less, when you're returning the promise.
yeah, when you do the write, yeah, and it's lock is a little bit of a misnomer. It's just nothing is blocked. What'll happen is the server just does that check, and you will have to rerun your code if something has changed. But nobody else was prevented from writing like with a more traditional write lock or something like that. Any more questions about transactions? Yeah.
If I want to run this calculation on the server side to make it secure, then I do not need to deal with those conflicts.
You potentially will. It depends how you are running that calculation. Because you could have something, like if you queue them so that you can guarantee that your process is only running one at a time, you shouldn't have to worry about it. But if you say have a bunch of servers, or you have something like Firebase functions which is not going to guarantee that, if two of them fire, it's not going to guarantee that they happen in a row. They might happen concurrently. Then you'll still need to do something like this. So unless you are providing that serialization of operations, even if you're running on a trusted server, you still need a transaction. Any more transaction questions? Okay. Okay, so when we started this project, we put it into test mode, which was allow anyone to do anything, which, as I said, is in general a bad idea for a production application. So here's an example of some more complete rules for this application. So a typical one that you'll see a lot is this if request.auth.uid does not equal null. That's just saying the user has to be logged in to do anything. You get a bunch of metadata in your rules to inspect and decide whether an operation is allowed. Among those things is the authentication details of the person trying to make the change or do the read or whichever. And then we have some other things like they're not allowed to change the name of a restaurant. Like once the restaurant's there, they're not allowed to change the name so that they're allowed to write the restaurant because we want them to update the average rating and the number of ratings, but we want to constrain the other things they could do. So this is just an example. You might also say like they're not allowed to change the category of the restaurant or something like that. Here we're just saying they're not allowed to delete restaurants. Once a restaurant's in there, it's in there. Should note that if you are using one of the admin SDKs, this is a thing that you would run on your own trusted server or some server process, again, Firebase functions or your own thing. That will bypass these rules. You're the admin, you've authenticated, you're allowed to do what you want. So this is specifically for like your untrusted client application, right? This is running in somebody's web browser, and you have no guarantee that they're actually executing the code you sent them. They're just doing whatever it is they're doing. Okay, let's see. And some other stuff like ratings. This is an example of how you would keep a user from faking who the rating is from. It's just saying the rating that they add has to match the UID that they have in their request data, or in their authentication data, sorry. So that's just saying, you can't pretend to be somebody else. This is just a sample of the rules. You probably want to, and it's very application dependent, but like think carefully about what operations you want to allow your users to do, and then see, like, try to match them exactly with expressions here. There is help for this now. One of the new announcements is that we have a Firestore simulator that can run locally on your machine, and that allows you to do things like write unit tests against your rules. If you say a user should be allowed to do this, you can verify it without actually going and talking to the Firestore servers. Or if you want to say, no user should be able to do this operation, you can write a unit test for it now. And then again, like the indexes, you can tie this to your deploy process. So you can say, all right, I've added this new feature in my application. It requires this special new access. I've written a new rule for it. So when you go and deploy your application, you can use the CLI to also deploy your rules, which is what we're going to do now. We have these sample rules in the project for you, and this command line will deploy them for your project. All right, and if you go back over to your project, you can see I have these rules now, and you can see they were just updated. You should have something similar. If you go back to the previous ones, you'll see the test mode rules that you had earlier. And this is helpful, especially if you make a mistake. It's easy to quickly roll back. Again, you can also roll back with the command line tool. I think the command line tool is a little bit more helpful because you can version control your rules, so the rollback can be tied to a rollback of the entire deploy, whereas this will just roll back your rules. If you have your code using the new features still out there, but you realize you made a mistake in your rules, you probably want to roll back the whole thing rather than just the rules. Let's see. Yeah. Are there any questions about security rules? Yeah.
How can I write unit test for these rules?
So, oops, not there. You can download a simulator, a Firestore simulator that you can run as part of your unit test process. And it's initially for JavaScript, but the iOS and Android ones are coming, where you can point the client. So right now on our web app, there's the JavaScript client is running, and it's pointed at production Firestore. You can point it at your simulator, and you can deploy rules to that simulator, and then you can try the particular operation, and then write an assert about whether it succeeds or fails. So when you write data and you get that callback for either this write went through, this write succeeded, or if it didn't succeed, if the rules blocked it, you'll get an error. And so you can write an assertion against that. Does that answer your question? It's the Firestore simulator. After this, I'll see if I can find the link for it. It was just announced, I think, last week. So, but it should be available for JavaScript.
These tests that are run by semantics or
so it applies the logic of what it's actually doing is it's running a process that evaluates these rules, and your SDK, your application, rather than pointed at Google's servers, is instead pointed at that process. And so it will get the same request data that you would get in production, and it will run the rules on that request. So if you try to say, like, I want to verify that a logged out user can't update any or can't read any data, right? You could have your SDK construct a request, like try to read data without logging in first, and then verify that you get an error when you try to do that. Because what will happen is the simulator will be looking at these rules, it'll be looking at your unauthenticated request, and it'll actually be executing these rules, and it'll hit this and say, oh, this isn't allowed, I need to return an error. It depends. If your rules are referencing data, then yes, you will need mock data for them to reference. So an example would be like update. If you want to update something, I mean, it needs to exist already anyway, but if you want to verify that this holds, you can't change the resource name, then you need some resource with a name to write that test. Any more questions about the rules? I'll see if I can find that link for the new thing once we're done. Yeah.
Is it possible to test that you have the user has, well, that's probably part of like more general question, but like we're trying to build and add like kind of administrator page for Firebase, like using
Sure.
and with like test if we're kind of logged in as an administrator user?
Sure. So I think the way that you would want to do that is maybe have a collection in your database that is who are the admin users, and say, does this UID exist there?
I mean the administrator user that actually has rights to modify the whole project. So
So are you?
there is admin SDK,
Mhm.
and you're able to access the data using admin SDK, but it's for server use.
Yeah. Yeah.
And is there a way to somehow use it from the client side with the authorization, or because probably like the way here that I got,
Yeah.
you have to kind of get do the query to the Google services and do all this required authorization to Google Cloud, and it's very complicated.
So I think if I'm understanding your question correctly, like let's say you wanted to allow not the admin SDK, not a server, but like a certain group of users are allowed to update resource names, right? Like they're they found a typo or whatever. They're the ones allowed to go edit it. You could include a clause in here that would say, the name has to be the same, or this UID must be present in that list of users who are allowed to do this. And then you could have the rules enforce something like that.
Yeah, so basically create a table with authorization.
Yeah, exactly. So, yep. Any more security rules questions? Yeah.
How complex they can get? Because what kind of language is that?
They can get complex, but they can't loop. So you're essentially evaluating down to a single Boolean. So you can tack on clauses, but that's pretty much it. And there's a whole bunch of resources for documenting like what variables are available to you, what request auth data contains, like what you're guaranteed is there and what might be there, things like that. Does that answer your question? Okay. All right. Let's see. I think that's all of the topics for the Code Lab. Does anybody have questions about Firestore or the real-time database or Firebase generally? I might be able to answer. Yeah.
Should I have a list?
Okay.
But I mean, concerning the Firestore and code and others, but there's a big question generally concerning cron for Firebase functions, and there's a hack that it's possible to use App Engine to run cron functions.
Yeah.
Do you think it will be like it's somewhere in the milestone that you're gonna add cron for Firebase functions?
So I don't know the roadmap for Firebase functions, but I do know that that is a common feature request. So I would expect that they're planning that at some point. But I can't tell you that 100% for certain because I don't know.
You expecting another one, maybe?
Is that more?
Yeah, so another feature that I've maybe spot somewhere that it's possible to add links to the collections, or to like a link from one document to a collection, or so, or vice versa.
Yeah. So one of the data types that you can use is a document reference. So you could say, that owner field that we talked about for a restaurant might be, rather than just a name, it is a reference to a document about that owner. There's nothing particularly special about it. It's helpful to like then be able to just use it when you pull it out of the document, but it's not doing anything magical. You could just have the like collection and document ID and construct it yourself via the API. It's more of a helper than anything else.
Is it helpful when you have kind of shared collection between a couple of objects and you may just get a link to the
Yeah, absolutely. Like it's a very helpful thing in your code to say like, if you have multiple things pointing to a document or referencing a document, like absolutely. It's just one of the questions we get sometimes is like, oh, if I pull that document, will it also pull the references, like the things it references? The answer to that is no. You have to go and get them individually. But you do have that reference right there, so you can do that easily. I guess actually that's another important difference from the real-time database. The real-time database, when you load up a location in the database, a particular object, you get everything. So if you have an object that each key points to another nested object, you're going to get all the data for all of the keys. Whereas with Firestore, it is shallow. So when we did that query to load up all of the restaurants, we weren't getting all of the ratings. Even though the ratings collections are nested inside each of those restaurant documents, we only got the restaurant documents. And if you want to go and get the ratings, you have to go and do that by yourself, which is kind of a good thing because you probably, like when we're displaying just, the front page of all the restaurants, you probably don't want to load up all the ratings for all of the restaurants you're showing. That's too much data. You don't actually need that. You might want it when you go and display a single restaurant. So it gives you a bit more control than the real-time database. Just another difference for those of you that have used the real-time database before. Yeah.
Is it possible to run some simple web-based application just on my computer without any communication with WhatsApp or like using the simulator? Is it simulator or just simulates functions?
If it's just on your computer, I think that should work because it'll, yeah, that should work. Yeah.
Is there any tool or library to access data, or there is only Firestore API?
So let's see. There are the client SDKs, which if you're building for the web or Node or Android or iOS, I'm going to heavily recommend that you use one of the SDKs because they're doing a lot. So one thing that we didn't touch on is when you make a write, we simulate that write locally first before sending it even to the server so that things tend to look like they're working while you're offline. Now, I mentioned there was that callback that you get when a write succeeds. We don't fire that while you're offline, so you still have the ability to know whether this has succeeded or not. But in general, like let's say somebody leaves a rating while they're offline, you don't want to like block the page trying to send the rating and like, there's no connectivity or anything. So you say, okay, it succeeded, like go back to the restaurants. And then when you come back online, we'll synchronize that to the server. It's one example of some of the things the client SDKs are doing. The admin SDKs are more of a sort of straightforward wrapper around the actual API endpoints. They don't do the they don't work well offline. They're intended for servers, so we just didn't include the offline pieces in there. All of that being said, the SDKs are open source. There are API endpoints. You don't need to use any of our libraries. It will be challenging, but they're available. Does that answer the question?
Yes.
Yeah, I would recommend using the client SDKs just because there's a lot of subtlety to the protocol, and we're trying to hide most of that so you don't have to worry about it. But again, they are open source. You can go and look at them. You can see what we're doing.
Maybe I meant if there is something like domain-specific language for querying data, because data is like JSON, so maybe some code notation would be more handy.
Yeah. So I don't know of anything like that, but somebody could certainly write one. You could definitely compile a domain-specific language into the proper Firestore API calls, the collection.document.collection, whatever, to index into a particular location. I don't know of anyone doing that offhand, but there's nothing preventing it. Any more questions?
What really is the hook? I mean, how do you send data?
How do we send data?
JSON or gRPC?
gRPC. Yeah, we use gRPC to talk to gRPC endpoints on Google servers. And again, the SDKs are open source. Even the Android one was recently open source. So iOS, JavaScript, which is actually in TypeScript, and the Android one and Java are all available on GitHub. Not just for Firestore, but for either all or nearly all of the Firebase client stuff. You can do Firebase-iOS-SDK or Firebase JS SDK, and there's most, if not everything, is there. So. Yeah.
Some project after time needs some like schema migration. So how do you solve this migration in Firestore?
Yeah. It depends on the migration. So the short answer is that it's kind of the same as a normal database migration in that if you have a lot of data, there's going to be a period of time where the migration is in progress. So we won't block reads or writes during that time. They look like normal reads and writes to us because a migration is going to be you iterating through all of your documents and adding a new property to them or something like that. My suggestion would be use the admin SDK. Make sure you script it and get someone to review it, just like a migration with any other database. But there's no special feature for it. Since it's a NoSQL database, there isn't too much of a schema other than the collections and documents that you add. And even adding a new collection is not there's nothing to do to add a new collection. You just start referencing it and it will exist. So the migrations in terms of the actual schema that we see aren't so much of a thing.
Some updates maybe for name of collection, or maybe some moving documents from one collection to two more collections. Maybe.
Yeah, so we don't provide anything for that. If you want to rename a collection, you are going to have to move the create a new collection and move the documents yourself.
But the clients are directly connected to the database, so it's a bit different to relational database where it's usually some sort of controller or API before the database.
Sure. Yeah. So there's
Maybe some versioning of
yeah. Right. So you're not going to have that server process sitting in between your clients and the database. So that is a consideration for migrations. You need to consider whether you can update all of the clients, or the clients need to be tolerant to both versions of the schema and do the right thing. So like if you, let's think of an example. If you are maybe splitting a document into two different collections because you've decided there's, you know, two sets of data where previously you thought it was just one, you're going to have, first of all, your new clients are going to have to be able to read the old thing, because that data is still going to be out there. If that's deployed before you finish the migration, they're going to have to maybe try the old one and then try the new one. But old clients are going to not know anything about this new migration that you're doing. So you kind of have to be aware of like what version of your applications are out there. This is less of an issue on the web where you can kind of just update things. But for mobile applications, this is absolutely a concern because there's no guarantee that you know, your users will actually update the version of the app they have. And I mean, this is kind of a concern for mobile apps in general, because again, like, right, there's no guarantee that users will actually update. Yeah. Do you have? Oh.
I need to maintain two versions of data.
It depends, maybe. If you don't like, so one of the things you could do is instrument your application version with some analytics and say like, okay, I'm supporting this version, or you know, I'm supporting all the versions that have greater than X% of my users, and use that to decide when to remove the old portions. So this is something that a lot of the app quality products can help with, is figuring out like, I have all these mobile users, what version are they on? You know, maybe is there something in common with the people who don't update? Maybe they're not regular users and you don't care about supporting them anymore, or things like that. But there's not anything special that Firestore is doing to enable that. Yeah.
Am I correct that I could use Firebase cloud messaging to detect which users, two users to update their databases? You know?
Yeah. So you can.
When you leave a new database or request request.
Yeah. So this is starting to get a little bit out of the products that I know about, but yes, I think you can build basically an audience of you know, users on version less than whatever, and target them with messages to say, hey, go update. That's something you can do. Yeah.
What about exporting for, dumping the database?
Yeah, so I believe there's a tool to dump your database to a Google Cloud Storage bucket, as well as BigQuery. And then for import, you probably want to use the admin SDK. Anything else?